Hey there, just getting started already. I stumble on my words in the first sentence. Erg. Anyway, it's stream 49, and today I'm working on a class to make requests of web servers. So in other words, it's an HTTP client. And I'm going to be using this as a means to experiment with libTLS from LibreSSL. TLS is Transport Layer Security. And I'm adding that to my code base in order to both make connections to servers through a secure channel and also to receive connections through a secure channel on my web server. So a couple days ago, I had this ambitious plan to enable our existing HTTP client to be used to send requests and receive responses back, and then to set up a little test program. Well, I got maybe halfway through the first bullet. And so today I'm going to work on what I didn't get to. And if I have time, start to set up that test program. So yeah, I didn't stream yesterday because I had to catch up on some other business stuff. So apologies for that. But we should be good to go for today. So let's see where we left off. Collapse all this stuff. Just looking. Yep, we're good. Okay. Looking up my stream setup. Okay, so we have tests for parsing. Why does it say request? That should say response, shouldn't it? Anyway, tests for parsing responses. Well, everywhere it says request, it should say response. Oops. I think because I copied that from the server tests. These say response though. Okay, anyway, so we have tests to parse responses, both good and bad. Let's see what else. All right, we have a test that talks to a server and does a GET request in one piece, or it processes the response in one piece. And then we have a similar one where right here, this loop, it will process the response one character at a time. I remember a couple days ago we were looking at this, and this caused a bunch of bugs in message headers to become visible. So we spent some time fixing that. So yeah, we have simple GET requests working. Okay, so I wanted to work on persistent connections. Client should hold on to a connection for reuse. And then if it's non-persistent, it should set the close token. Maybe we'll start with this one because right now it's not holding on to the connection. Actually, it's sort of leaving it up to the user, right? Because let's go look at that. Client has this struct transaction, and the transaction. Okay, yeah, the connection isn't visible in the transaction, but in the implementation, in transaction impl, which is derived from transaction, it's got a connection object. So essentially, the user of the client class will end up holding on to a connection to the server. I guess what we should do is when we complete the transaction, we should decide whether or not we're holding on to the connection or not. Actually, what we can do is we can just always release it. And then if we wanted to keep it, we would keep it in the client itself. Yeah, let's start off with that. So let's write a test for this. What I'm thinking of is connection released after transaction completed. So we'll let's start with the previous test. So if the client, have the client make a simple request, provide a response back. All of these asserts though we can remove. Wait for the client transaction to complete. I'll leave that assert in there. Right, so after the transaction completes, verify the connection was released. How are we going to do that? I think what we'll do is we get we get the connections here. And we get one connection there. What we'll do is we'll hold on to a weak pointer to, what is that type exactly? Mock connection. Then we'll release our handles to it. Like that. And that needs to be an auto. Why is that a reference? It doesn't need to be reference. It's already a shared pointer. So is that, yeah. That's a reference though. Okay. So I think what we do to verify is we assert, well, we can do, yeah, assert. Assert true that connection weak dot lock equals null pointer. Okay, so I had run our unit tests before I started streaming, actually while I was starting up. So everything was passing before. Now we should see that it fails. I can't run my tests. I don't know. Okay. Too many tests, I have to start using the filter. Connection released. Right, so we see it fails like I expect it to fail because we haven't written the code correctly. Let's go do that now. Right, here's the transaction implementation. Here's the complete. I believe what we do is release the connection. Let's see if that fixes it. I wonder why I had to rebuild a lot of things there. Oh, because everything includes client.cpp. Okay, so that fixed our test. Now I think what we should do is when we close a connection, we need to close it well. So duplicate that test. Connection released. We'll say connection closed properly. And we'll say it's a non-persistent connection closed properly. Set up the client, have the client make a simple request, provide a response back. Actually, before we provide the response back, we'll look at the incoming request and we'll expect, or really assert, expect. I kind of waffle on whether to do assert or expect. Assert will stop the test if it fails. Expect will mark the test as failed but continue. So sometimes it's actually a lot of the times it's better to do an expect to see all of the places where the test is failing. I guess where you want to use assert is if it really doesn't make sense to continue the test if that assertion fails. Okay, so what was I doing here? Right, expect equal that we want to see close in the incoming request headers. Actually, it's a Boolean, isn't it? Expect true. That the incoming headers has a header token in connection named close. Right, and we provide the response back. Do we set the close flag back again? I need to look this up. When in doubt, consult the manual. It's RFC 7230. I pretty much memorized this by now. Let's look for close. Actually, let's look for connection because there's too many hits on close. Actually, maybe better would be connection colon. There we go. Okay, connection close in either the request or the response indicates that the sender is going to close the connection after the current request is complete. Client that does not support persistent connections must send the close option in every request. Server that does not support persistent connections must send close in every response. That does not have a 1xx informational status code. That, by the way, that's what's used for things like upgrading protocols to WebSocket, for example. Alright, so it just says you're supposed to set it before you close. Oh, what's this flag mean? New version of Visual Studio is available. What did they do? Okay, so I have one. They have now 2 available. What's in the release notes? Bunch of things fixed. I'm just glancing through to see if there's anything that I care about. I don't actually know what that means. Publish single file. Publish probably. Or like, what do they call it? One-click publishing. Cannot type close brace. Cannot type close brace, really? Because it looks like I can type it. I don't know. This to me is a bad bug description. IntelliSense broken number 9999. Also a bad bug description. These don't even have bug links. Very sloppy. Okay, anyway. I don't think there's anything critical to look at. I'll upgrade later. Koba, how's it going? You have the best news. It is flying you out for an on-site. That's awesome. Congratulations. What does it say? This is what we do in World of Warcraft. Grats. Let's see. Yeah, so we want to provide back the same thing that's required. Yeah, I'm like the same. I try not to get my hopes up too high as well. Set your expectations low so that when something good does happen, you'll be pleasantly surprised. But I'm sure you'll at least gain a lot of experience with the on-site interview, so. And you turn it into something fun. You're flying out there, if you haven't been there before, go see the sights or something. But I would suggest doing that either well before or after the interview. You know what I mean? Okay, so we're expecting the closed token and we're going to respond with it. We should probably then also expect that the client closed, right? What did the spec says it closed after, didn't it? Will be closed after the completion of the response. All right, so what should we wait for first? Wait for the client transaction to complete. Let's wait for the client to close their end of the connection, because we kind of want to see them do it first. So assert true. It's not going to be in the transaction, is it? It's going to be on the other end of the connection. I always get these sort of mixed up. So is that our end of the connection, the server's end? I'm going to assume so. Wait broken. I think that's all we need. Let me double check that this is what I expect. Broken. And break is what sets broken, right? Okay, cool. So this will fail, I'm sure. What's the name of this test? Non-persistent connection. Actually, let's look at all client tests. Yeah. So we did not see the connection close, and the connection was not broken. Well, let's go fix that. So where are these complete functions called from? Right, so here, where the response was complete or we got an error. And then here is another one where it was unable to connect to the server. Okay. I guess we're always going to do it, right? So do we want to do it while we're holding on to the lock? I'm trying to think if that would re-enter the transaction. Maybe. So let's preemptively fix that. Actually, hold on. Need to avoid the issue of deadlock here. So we really shouldn't be calling a callback. We're not calling a callback. What I want to say is connection break false. Reset the connection, basically, because we've gotten the response. Right. And actually, before that, hold on, does break? Let me look at something. We do a clean break. What does it actually do? Closing is true, yes. Okay, that means we're not going to send anything more. Okay, that's good. So we can close cleanly early. What happens if we're already closing cleanly and we tell it to break uncleanly? Does it break immediately? Immediate and stop processor. Yeah, it'll close immediately. Okay, so we should be good calling it there. So if nothing else, it will reset the connection. Actually, when we release it, it'll probably do it anyway, but hold on. Where do we actually set or send the request? There we go, request. Here's where we send the data. So at this point, we can also connection break, but we want to do break gracefully. Basically saying we're not sending anymore, and we'll close after we've received everything back. And then in addition, we need to set header connection close. Let's see if that does it. Yep, it did it. Let me run all the tests to make sure. Okay. I'm wondering if we should enhance the test to make sure that it did a graceful close. We could do it here, yeah. So let's enhance this a little bit. So we have this broken flag, right? Oh, we have a broken gracefully. Okay, never mind. So we can say assert true. Connection broken gracefully. And then up here, we don't have to await. We can say we expect true that the connection is broken. And false that it's broken gracefully. And then I'm going to reset the broken. So that when we await it really be broke, await the final break at the end. Right? So the test should still pass, hopefully. Oh, it didn't. 680. Oh, I got that backwards, didn't I? This should be false down here. Gracefully broken at the conclusion of the request. Ungracefully broken at the conclusion of the response. Yeah, there we go. Cool, let's check that in. Right. Oh, let me check these changes in separately. These were sort of just badly named tests. Okay. Fix names of client tests. Right, so client. Release connection and close properly. That's a little bit too long. What do I want to say for the whole thing? Release connection and close properly at the conclusion. Well, this couple points. When a request has been sent, gracefully close the connection. These are multiple bullet points, actually. Set close token in connection header of each request. When a request has been sent gracefully close to the connection, release connection and close abrupt. It's the other way around. Close connection abruptly and release it at the conclusion of the transaction. Okay, now the summary. Client. Proper connection close handling. Alright, so that's this one, non-persistent connections. So let's do persistent connections. Then we need to decide what's the default, persistent or non-persistent. Let's see. I suppose we should make persistent connections the default. Which means we should do a little bit of refactoring here. For all these tests which make a request, we'll add a flag. And the flag will mean whether or not to keep the underlying connection persistent. And so false will mean that it's not persistent. Actually, I'm second guessing this. Maybe what we'll do is we'll have a default. So in these tests, we don't care. On this test, though, we do care. We need the connection to be released, so it needs to be not persistent. And this one, it's definitely non-persistent. Right? So we will now add a parameter to request. Where are you, request? Okay, there you are. There's a request, and then bool persist connection. This flag indicates whether or not the connection used to communicate with the server should be maintained or kept open after the request to possibly to be reused in subsequent requests. All right. So right now, oh, I need to set the default, don't I? Default will be true. That's refactoring, so it should not show up as any test failures. Technically, it's a feature add, but I'm gonna say it's refactoring for now because we don't support persistent connections. All right, client refactoring. Rather than connections being implicitly non-persistent, have the user specify whether or not to persist a connection when a request is made. Note, persistent connections are not yet supported. They weren't supported before, still not supported. But I don't want that check-in, especially the addition of that flag, to mislead people into thinking that you'll get something implemented correctly if you say true, especially since it's the default. So now let's implement that. So test, right? So I'll copy from our base test here. And we'll say client, simple client request. So it'll be 2 requests, same server, reuses persistent connection. All right, so set up the client, have the server make a simple request. Oh, I can remove all of that. Provide a response back to the client in one piece. Wait for the transaction to complete. Then we're going to make another request. Have the client make another simple request to the same server. Expect the same connection to be reused. So how do we check that? So we'll change that to bar this time. Oh, remove some of the assertions I kind of wanted. Oh yeah, let's bring that back. Okay. So we have 2 transactions now, so I'm going to reuse the transaction variable. Okay. Let's do this. So what does await connections do? Waits up to 100 milliseconds, so we'll assert false. Await connections 2. What that'll do is it'll wait for a second connection and then assert that it doesn't get it. It'll have the same connection reused. Okay. Don't need that. Don't need that. Now we'll do await request 2 and make sure it's the bar request. And then everything else. Okay, so it doesn't really matter what we respond back. I guess we repeat the same assertions from before. Actually, I'm going to have it return something slightly different. So different header and a different content. Poggers. That's 7 characters. Hello? 7 character poggers. Okay. Response encoding. Let's just make that auto, and so I can reuse it there. And I'm going to reuse response by doing this. Making another one and replacing the old one. And I think the same, okay, I don't need this. You know, actually I do. Incoming request. Actually, can I do this? That's not what I want. I'll just make a copy of the incoming request. Alrighty. We should also make sure that the connection wasn't closed. Oh, we should actually make it persistent. Not rely on the default. This one doesn't matter though. I just want to make sure it gets reused, so... Actually, that makes me think we should have another test. Second request with persistent connection closes connection second request non-persistent with persistent connection closes connection. Yeah. We'll fill that in a bit. In other words, if you make a persistent connection in your first request and then your second request you say false for persistent, you want it to kind of close the connection at that point. All right, so we'll do an expect false connection broken. We don't expect it to be broken there. Okay, we also do not expect, so expect false that the incoming request headers has header token connection. So it shouldn't have connection close in the request either. All right. So this is going to fail. I expect it to fail this time. Oh, and it didn't even compile. All right, same kind of deal. I'm reusing a variable, so I need to reassign it. Okay, yeah. It was broken when it shouldn't have been. And then it also actually had the connection closed specified when it shouldn't have been. And it crashed. Probably because... Why? Maybe in there. Probably in there. It released the connection, I think, and then we're calling a delegate on calling a delegate which captured something which, yeah, so it shouldn't work. So we kind of expect it to crash right now. So let's implement it. So first things first, right? Don't break the connection if it's persistent. So I suppose what we'll do is we'll store this persist connection in the transaction. Right here, transaction persist connection. So we have to copy it. I'm going to steal the documentation for reuse in the transaction implementation. Right here. So bool persist connection. Doesn't matter what we set for the default there. This flag indicates whether or not the connection used to communicate with the server should be kept open after the request, possibly to be reused, right? So we assign it down there. We should also not set that connection close if we're persisting the connection, right? And actually also down there too. So this Right, and then here as well. Only if we're not persisting the connection do we break it. And then lastly, actually not, maybe next to last, would be we need to actually hold onto this connection somewhere else besides the transaction if we're going to reuse it. So that's where we're going to add something to the client's implementation. Transaction impl client. So client impl here. So we have transport and timekeeper. Now let's add I think it's going to be a map of some kind, but what? What are the keys? It's something to a shared pointer to a connection. So persistent connections, right? So this would be the host and port number, I believe. So I guess we'll just make it a string. We'll just have to construct that string from the URI each time. This is used to hold onto persistent connections to servers. Right. Okay, so we need map. And we should also include memory since we're using shared pointers everywhere. And then in request, let's make this one an if else, and then so if we persist the connection, actually does the client not have its own mutex? Probably need to add one. It doesn't. Okay, so it's not thread safe. Actually, we don't need to worry about that yet. So it'll be impl persistent connections, and then here we need an identifier. So server ID equals transaction connection. We need that server ID. So I say we do this, we format it as string colon PRIU16. And for that I need int types .h. So the first part is the host name or address. So we already have that. Actually, is that already a string? Convert to a C string or use appending. Doesn't really matter, does it? So then, do we have port? We have port, okay. Port. Right. So this isn't going to reuse the connection, but it won't break the connection, so it should get further in our test. Right, so we got further, it got to where it's crashing. I actually want to see that crash, so let's see if this is set up. Okay, it is set up to go, so now we're going to go. Ah. The connect failed. This set up to fail if on the second request, maybe? I might have set it up that way. Let me expand all of the outlining stuff. It would be in our mock transport, wouldn't it? Connections allowed. Yeah, so it's not allowing the connection. And then it was crashing when it was trying to... Oh, actually that's bad. That's a bug. So complete is calling break. But if the connection is null, yeah, so we need to say if not, basically, or it'd be better maybe to say if connection is not null and we're not persisting it, then we break it. We always release the connection because if it's persistent, it's the client that holds onto it, not the transaction. So that should fix the crash and then should fail the test later. Oh, nope, it just crashed somewhere else. Let's see where it is. It crashes on send data. You know what? We didn't return early. We should return early. Return transaction. Okay, not crashing anymore, but it's not getting a second request. $742. It didn't get a second connection, but it didn't get a second request either. Right, because it's not reusing the persistent connection. So let's do that. I think we should construct the server ID earlier. Up here, because we need to make the decision at this point. Do we make a new one or do we reuse one? So let's look it up here. Const auto old connection, or let's say it's persistent connections entry, because we're going to look it up in persistent connections. Find server ID, right? If persistent connections entry is equal to the end iterator, it means it's not found, then we can create a new one. Okay, we'll say else transaction connection equals persistent connections entry dot, or is it arrow? Arrow second. So now we're reusing the old connection. All right, so it's getting a little bit further. 760. Okay, so the transaction didn't get completed. Ah, okay. Oh, is that, I think I know why. I know why. Right, because when we made the connection, we captured the transaction, that connection, right? The second time through, that transaction no longer exists, and so it's not sending it to the correct transaction. So we kind of need the connection to know which transaction is currently being used. So we kind of need to rewrite these delegates so that instead of going to one transaction, they go to like the current transaction for the connection. So that's sort of additional state to add to the connection. So that makes me think that this persistent connections, it shouldn't just be to a connection, but it should be to like a connection state. And then we'll have to add a connection state here. Well, not there. Let's put it here. How come it wants to indent it like that? And then in the connection state, we'll put the connection. I don't know why it's wanting to indent that. Weirdly. Okay, anyway. This holds on to all the information but a connection to a server. This holds on to all the connection, all the information that a client has about a connection to a server. All right. HTTP. This is the connection to the server. And then we're going to have, this is the current, this is, we want it to be a weak pointer, right? This is, this refers to the current transaction, if any. That is currently being made through the connection. So standard weak pointer to a transaction impl current transaction. All right. So we're not going to capture transaction weak anymore. So what do we capture? For a non-persistent transaction, we need to make a connection state even if it's not a persistent connection. So it needs to be shared. We need the transaction to be able to get back to it even if it's... Okay, so let's make const auto connection state equals make... Hold on. Standard make shared connection state. And then connection state current transaction. Actually, hold on. This is only if it's not being persisted. So this becomes shared pointer. So if there is none, we make a new one. And then, right, the connection state connection. Else, the connection state, right, is that. Okay, I need to change this because we're sharing these connection states now. Sharing it with the transaction. Not the transaction, the... we're sharing it with these delegates. So instead of transaction weak, it will be a weak pointer to the connection state. So connection state weak. Connection state. So it's 2 levels, isn't it? Because we might have abandoned our connection. So it'll return at this point. We might not have abandoned the connection, but the transaction might no longer exist, right? So if that's the case, so we need, there's 2 steps here. The transaction equals connection state current transaction lock if the transaction doesn't exist anymore, then return. All right. So if the connection is still active and the transaction is still active, then we give the transaction the data we received. So these weak pointers are important. That one, basically that one and this one, both weak, so that we don't have a circular dependency, or circular reference really, which would keep the objects there forever. So the only strong reference to this connection state will be in the persistent connections, right? That's the only strong reference we keep. And then connection state has a strong reference to connection, so any delegates we give to that connection can't be strong references back to the connection state, so those have to be weak as well. The transaction pointer here is weak because we want the only strong one to be the user of this class, of the client class. Like if they release the transaction, they don't care anymore, so essentially we wouldn't process any response back if the user doesn't care, right? Okay, I think this will do. So if we did find the connection as a persistent connection, we reuse it. We don't need to set up the delegates again, but we do need to set the new transaction. Current transaction equals this one. Actually, we didn't set it there either, did we? So we do it in both places. There might be a race here, right? Setting this current transaction and then getting it here could race each other. So, maybe we need to have a mutex in the connection state. Yes, I think so. This is used to synchronize access to this object. All right, so we only need to briefly lock it. So we'll have a shared pointer to a transaction impl. We'll do this assignment here while doing a lock guard. Oops. That kind of lock guard, right? So this accesses the connection state in a critical section. We need a similar thing when we do this. All right, I think that's good enough. Although this is getting a bit long. Okay, so that persists the connection. Now we need to decide if it's not persistent. We should probably remove it from the persistent connections. Where do we do that exactly? Actually, it doesn't really matter. We could do it anywhere. How about here we add it, and then here we'll remove it. So void impl persistent connections.erase server ID. That does nothing if it wasn't persistent before, but if it was, it'll remove it. Okay, what did I do wrong? This is one of those irritating things about Microsoft's Visual Studio and its template library. So when you're in the errors and you click on an error, it takes you to the source code to the standard template library. I'm like, I don't know. There's no bug there. I want to see the bug in my code. I wish it would do this for me, but you have to kind of look at the output window and see. See, sometimes it's the first line of your own code and sometimes it's not. So in this case it was. So I was doing an assignment here from connection to connection state. Right, so this becomes connection state. Connection state. All right, so let's run the tests again. Got a crash and some test failures. Let's focus on this first failure. See why that might be failing. Line 548. So it's failing to receive the request. Okay. It got a connection. It just never got the request from the connection. I think I broke something. Let me run through this code. So in this case, it's the default is it's persistent. So it's gonna persist the connection. Let's see what happens. It won't find it. Right, it won't find it, so it'll make a new one. Oh, you know what? I never actually initialized that, did I? That might have been why. Nope. Anyway, that was a problem. There must be more than one problem. So the error is it's never getting the request, so it's never getting into there, I think. No, sorry, it's down here. It's not doing this send for some reason. Oh, okay. I put the connection in the connection state, but I never moved it to I never gave the transaction a copy. Right, so the transaction's connection is the connection state connection. That might have been it. Yep, that was it. So let's run all the tests again. It's not crashing anymore. Why did I call it connection released after transaction completed? Oh, that might be an old test. Oh, I just didn't update the name. Connection released non-persistent. Connection released after transaction completed. So the problem is on line 653. It's not completing. Right, so it's something wrong in a non-persistent connection. So it won't, it'll go into here, make a new connection state, make a new connection. Oh wait, if it's not persistent, actually I think the transaction needs a strong reference to the connection state, doesn't it? Yeah. So the connection state has a weak pointer to the transaction. The transaction needs a strong one back to the connection. Where's transaction? Here it is. So, no, it has a strong one. Is it? Hold on a sec. The connection. So something needs to hold a strong reference to the connection state. Hey there, Rally Monkey. Connections. So what does transaction actually hold on to? Just hold on to the connection? Okay, I need to rethink what I'm capturing in this delegate here. But the delegates associated with the connection needs to somehow get back to its state. So I think I was thinking of this wrong. The connection state is, the connection state holds on to a strong reference to the connection. So the connection can't have a strong reference back, but what holds on to the connections? I guess it would be transaction. Transaction info has to hold on to a connection state. This is the state of the connection to the server used by this transaction. All right, so if connection state not null pointer, then we release the connection state. Yep, okay. And it's just that. Actually, we can kind of reduce that. We have our own reference. And then let's see. Right, I think that might do it. Although it's getting to the point where there are three objects pointing all to each other. I might want to make a diagram to describe that. Okay, I need to reverse the order of declaration here. And okay, these two objects refer to each other. Right, I need to put connection state first. That's the weaker, so to speak, of the two. And it has a pointer up to a stronger object. Oh, I never wrote a documentation for that. Okay, let's put it in there then. This is a client transaction structure that contains the additional properties and methods required by the client's implementation. This being the client transaction structure, we're deriving from it because we're adding the connection state and these other flags and stuff and methods that we're using in the client's implementation. All right, so it's not going to like that I use this symbol before I define it. So actually, I think if I just do struct here, it'll be fine. Yes, okay. Cool, so that made everything pass. All right. Now, we did have this test. Second request, right, so we want to make sure it removed it out of the persistent connection. So I think the way to do that is we verify it closes it, and then we should probably verify that it doesn't get used again, or that a new connection gets opened again. So we'll be making 3 requests here. Set up the client, have the client make a simple GET request to provide the response back. We don't need to do this anymore. Have the client make another okay, this one should say have the client make a simple request and make use a persistent connection. Using a persistent connection. That comment should be in the other test too. Have the client make another simple request to the same server, this time with a non-persistent connection. And then we don't need to expect the same once the other test confirms that. So I don't need to do this or this. I do want to await the second request though. I don't need to do these expectations, which means I don't need to do that. Provide a response back. Expect it to complete. Right, and then I'm going to do a little bit, not a little bit, I'm going to do the same thing I did in the previous test for the second connection, but this time it's the third connection. So have the client make a third simple request to the same server. Expect a new connection to be made this time. Actually, this should have been a false. And we need to make sure that it closed it. So that would be here, right? Expect true connection closed, broken. And then also expect true connection broken gracefully, and then we'll reset connection. We'll reset these. Because we're going to expect this down here. After we provide the response and it's completed, we'll expect it was broken ungracefully. Actually, makes me think the test I did previously wasn't quite right. Yeah. That could be an expect. Yeah, I forgot to reset this. All right. Okay, third request. We don't care if it's persistent or not. Oh, I need to update. Allowed, what was that called? Allowed connections? Connections allowed. And that was in the mock transport. So back when we made the mock transport in this third test, transport connections allowed equals 2 this time. So here we will assert true that we get a second connection. And then after that, we need to change our connection. So, why is that? Why did I make that a reference? I don't know. So this thing here. It's not the first connection, but the second connection now. And we'll only have one request on it. Like that. And we'll change this to be spam. Spam. All right. Provide a response back. Something that's different from the first two responses. So, foo feels bad man and body. Hey guys. All right. This actually might already work. I don't remember if I implemented everything. That's what the test is for, right? Okay. Looks good. Let's check it in. I have this funny feeling that I forgot something. Which would mean, if it's true, that would mean that I have not implemented all the tests correctly. But I guess I'll discover that later. Let's check these in separately. Those two hunks. And these lines. Because that was repair to a previous test. It's more of like cleanup. Clean up one of the client tests. Right, so this was implementing persistent connections. Oh wait, I think I do remember what I forgot. Yeah, so where do I? Okay, I don't know where it is. So we have this, that the close is not set, right? For the second request causes a close, we should actually expect it this time. So this stuff here. Hold on, I'm getting confused. I'm missing a bunch of stuff here. Okay, cool. This is what I'm missing. I don't need that there. I need this here because I don't need that. I want to expect true that the connection close was set. We should also set the connection close as well. And really we should do the right thing in saying this. Down here. Connection break false. Okay, the third one, we don't care if it persists or not. All right. That's what I forgot, I believe. Okay, it didn't break. It's already good. Okay, I think we're good. The client has support for persistent connections. All right, so then it's going to get a little bit, what do you say, interesting here because we're not handling connection breaks from the server, so, or timeouts. Really, we need to handle both. Timeouts, we'll need some kind of thread, a worker thread that wakes up after a timeout and cancels the connection, completes it with the timeout thing, right? So that's a little bit more elaborate. This one is maybe a bit simpler. We need to register a break delegate to complete the transaction with the special status, right? I got a bug flying in front of my face. Go away, bug. All right. Not a computer bug either, it's a real bug. These tests are getting complicated, so let me pick a simpler one. Simple request one piece response. So here, we'll copy it and paste it. We'll say simple get request connection broken by server before response completed. So the client, have the client make a simple request. So instead of providing a response back, break the connection to the client, right? So no response. Instead, we're going to call the broken delegate. Oh, it's like told if it's clean or not, right? Graceful. So false. So it should complete. What status should we expect? I'm not sure, so maybe I'll look it up. We need to manufacture a special response. Like, bling? Probably in the other RFC, right? 7231. Yeah, so I don't know, one of these, maybe. What did we pick for this special code where we couldn't get a connection? 503, service unavailable. Okay, maybe we'll use 504 for the timeout, and maybe we'll use 503 again. Yeah, I mean, these are intended for proxy servers. We can consider the class as being a sort of a proxy. So yeah, let's do the same. Let's use the same code. So we'll expect a 503. Service unavailable. Expect a special status code indicating the server is unavailable. I'm wondering, what happens if actually we can test this idea. What happens if we're in the middle of a connection and then we just break our side? What does Chrome do? Let's see. A little experiment here. So we'll do a wstage wserve. Then we'll have Chrome talk to our web server. Localhost 8080. Yeah, fine, whatever. And then we'll set up our web server to run in the debugger. Use Netscape Navigator. Can you even still get that? Is that still around? Breakpoints. No breakpoints. I want to set a breakpoint in the server, like right before it's going to respond. So where would that be? Server data, send data, issue response. Yeah, right here. So go and reload. And then here I will just abruptly terminate the debugger. Error empty response. Okay, I kind of want the debug tools open. More tools, developer tools. So let's repeat that experiment. Reload. And then stop. Huh. It doesn't actually have an entry for the actual request. Maybe it doesn't consider it made the request until it gets something back from the server? Hmm. I guess we can try Firefox. So while that's going on, let me open a new window in Firefox. I'll go to localhost 8080 static index.html, enter, and then hit. I forgot to set up the debug tools again. Web developer network. And then reload that guy. stop the server. Okay, it does have a get. But it doesn't tell me what the response was. So we don't know what code, if any, it considered to be the result of that request. I'm kind of leaning towards using special codes so that it's not ambiguous. Because these two browsers do behave differently. If they were to actually get a 503 from the server, they would show it here. So let's go back to our test where we expect 503. Let's change our expectation. Okay, wasn't that in two places? Didn't I have a test for when the connection's not allowed? Get response. Maybe I forgot to make a test for it. I think I forgot to make a test for it. So let's make a test for it. So that's where it's broken, right? And we'll have one simple get request connection refused. So like this. But when we set up the transport, we'll say connections allowed is 0. Actually, all of these extra asserts can go away, can't they? Which means I don't need any of that stuff. Well, we need to hold on to the transaction and the connection. Don't need the incoming request though. Same thing here. Oh, did I delete too much? I need an await connection. Action equals. Alright, but this one will be a false. This one will be a true, but only one connection. Right, so what codes should we have? I looked this up the other day. I didn't really like what I saw, so HTTP status code for connection timeout. Yeah, that's a request. What about a connection timeout though? Maybe there's something in here. Request a gateway timeout. See, but if it really is a real gateway, yeah, see, Cloudflare has extra codes for this. I don't want to use, okay, I want something that's unique. These are, okay, unofficial. There's a network read timeout. Is there like reserved for application? HTTP status codes are reserved for application use. Ah, here we go. Here's something similar. better to be explicit about the separation of protocols. I kind of agree with that. Okay, so that gives me an idea. So how about instead of expecting a certain status code, we will add something to response. Actually, let's add something to transaction. We'll say state. And we'll expect it to be equal to HTTP client transaction state broken. All right, and then down here, it'll be state connection failed. Connect failure. Connect unable to connect. Something like that. And I'll just build into the first test we had where it does get through. I'll build in something there. Right here. Right, so we'll expect it to be state completed. And let's have one for where we haven't yet completed it. We'll have it be state in progress. All right. So we need to introduce the state and then these state values. So maybe even before the response, it'll be state equals in state in progress. So types. These are the different states that a transaction can be in. All right. So enum class state in progress. The transaction or the connection to the server is still being established. Or the request is still being sent, or the response is still being received. Okay, we have in progress, and then we have completed. A response has been completely received. And calling, there's a method right here, right? Await completion. Method will return immediately. Okay. The connection to the server could not be established. Actually, we'll move this comment up here. Unless this, well, I'm gonna move it down here actually as a note. This method will return immediately if the state is not in progress. Is that too long? It is too long. It's 80 characters. There we go. Okay. Well, I forgot what I set for that code. Unable to connect. The server disconnected before a complete response could be received. That code is up here, broken. All right. So the tests now reflect our expectations in our design, right? But they're going to fail because I have not updated the code. Oh, and I should probably implement a print to make this look nicer. So let's copy from, where is a good print to? Let's search for print to. Yeah, like this. So we'll copy that over to here. And it's supposed to be global, right? So this is a support function for Google Test to print out the values of the HTTP client transaction state. That's the complete name, right? Yep. This is the transaction client transaction state value to print. All right. Now implement it. Client CPP probably at the bottom is good. All right, I need, oh wait, hold on. I think it needs to, this within, so within the HTTP namespace, I guess that's okay. But I think I need OStream, technically. OStream. And let's just kind of copy this implementation. We'll change out all of the names here. In progress, completed, unable to connect, broken. And then there's the unrecognized one. So, in progress, completed, unable to connect, and broken, all in caps. Actually, let's make this all in caps too. Those are sort of the error states, aren't they? Now when I run the test, it should look nicer. So we expect it to be completed, but it's in progress. Well, look at that. We got some errors thrown. Oh, because we're not supporting it, yeah. We're probably calling a broken delegate, which is null. Let's build that into the test. This one right here, right? So we should assert false that connection broken delegate is equal to null pointer. That's probably why that test is crashing. Oh, wait. It was the other test, wasn't it? It was in the connection refused. Okay, I don't need this actually. Shoot, I'm curious where that's crashing. So let me run the unit tests again. Ew. Okay, the connection state is not null, but the connection is. What's all this stuff? Huh. Oh, you know what? We have two classes called ConnectionState, don't we? It's confusing the debugger. We have one here, then we have one here. The debugger is getting confused. Do I want to rename it just to make it easier to debug? I don't know. I guess there's no real harm in it. So in this file, I can replace connection state with client connection state. Whole word case replace. Oh, hold on. I misspelled. Replace. That's just for the debugger. Maybe I should make a note for this. So note. I was going to type I wanted to, but you don't really want to use the first person. It would be better to name this connection state, but this confuses the Visual Studio debugger because server has its, because the server implementation has its own connection state structure, which is obviously different. All right, now let's see that crash again, and I want to see the debugger not confuse me. Connection state. Right, the connection is empty. So the connection, it's not that the connection state's never null. It's that the connection in the connection state could be null. That was the bug. All right. So 3 tests fail. One should be completed, but it comes back as in progress. Another one is because we haven't implemented our handling of server breaking the connection. And the other one is, again, the state is not set correctly. So let's set the state correctly. So it's at 503, right? And so instead of status code 503, we'll say state equals transaction state unable to connect. All right. That should fix one of the tests. Cool. Now we're down to 2. So the completed, that's also an easy one to fix. So incomplete. Hold on, no, it's not complete. It's where we call complete from when we get the response back, right? Data received right here. So if it's complete, This is in the transaction, right? So we just say state equals complete ed. All right, now we're down to 1. Okay, so and to handle break, we need to have a broken delegate. We don't have anything right now, so let's add one. So we have to do the same kind of thing. Yeah, the same kind of deal here. So let's just delegate it to the transaction. Oh, hold on. No. But let's not. We can simply say that the state state action state broken. And what else? We need to complete it, right? So transaction complete. Do we need to do anything else? We really should remove it from the persistent connections. But our test isn't going to test that yet. I need to think about how I'm going to test it. I also need to take a couple minute break. So let's get that to pass. Okay. I think we'll check that in, but there's one more test we're going to need to add. Let me do the check-in first. All right, we added a state in order to support connection breaking by the server and connections being refused. So client add detection of add transaction states and detection of server connection issues. So I'm going to take a couple minute break. So this is probably maybe a good chance if you're watching to go get something to drink. It'll only be a couple minutes. And when I come back, I need to handle what happens to this connection state. If it's a persistent connection and it got broken, we really need to remove it from the map. And that might lead us into this last part, where if it times out, we also want to drop the connection, remove it, and if it was persistent, remove it from our persistent connection map. So yeah, I'll be right back in a couple minutes, all right? Be right back. All right, that might not have even been a couple minutes. So let's make a test to sort of catch where we didn't close the persistent connection. So kind of like the test we had where we reused a persistent connection, but we'll break it. All right, 2 requests, same server, reuses persistent connection. Kind of like this test, but we'll alter the situation a bit. So it'll be persistent connection broken persistent connection not reused. So set up the client, have the client make a simple request, and we'll say we'll break the connection from this server. And so that is connection broken delegate. Let's do an assert false. That connection broken delegate is null pointer. We don't want to call a null pointer in the test. Alright, so none of this stuff. Wait for it to complete. Have the client make another simple request. Expect a new connection to be made, which means we need to allow 2 connections. So transport connections allowed equals 2, and then we will assert true that we get 2 connections, and the new connection will be the second one, and we'll await 1 request from it. First request yeah. And do I care about this stuff? Not really. Sort of redundant. Other tests test that. That can do that. All right. Right, so it's not working because it's not reconnecting. It's trying to reuse the broken connection. So it's not enough to say that the transaction is broken and to complete it. We also need to somehow tell the client that that connection's broken. So here's where I think I'll introduce a thread that will do it for us. Although I need to be very careful about deadlocking. So it's just a reminder to me that I need to move away from these mutexes to something more like a task queue kind of thing. That was going to be the subject of one of my upcoming streams. Where do I have that? Future streams. I want to bring in this. I have a class called I think it's task queue or something else. Actually, I think it's called dispatcher. So it's like what we've been doing with our worker threads, where it runs a thread and you can post jobs to it, and then when it wakes up after a job has been posted, it just executes the job. And so we would run everything through the dispatcher that otherwise would need to be protected by mutexes, and then we don't need a mutex because it's all just done on one thread. The cost of that is you can never do anything in the caller's thread context other than create a job object and queue it. So there's always going to be a task or thread swap or switch. So everything's a little slower. You just make your task something that you're not going to do millions of per second, and you should be fine. We already have condition variable mutex, so this is going to be in the client's implementation. Which means we need to protect this persistent connections with the mutex. So standard mutex, we'll just assume it can be a single non-reentrant mutex for now. This is used to synchronize access to the object. Very generic. And then a condition variable. This is used to wake up the client, wake up the worker thread. So it's just going to be condition variable wake worker wake condition. All right, and then we'll need to have, what do we need to have? A flag. This flag indicates whether or not the worker thread should stop. Stop worker. False. And then finally, actually, do I need a finally? I guess I don't. No, I do. I need the thread. This thread performs background housekeeping for the client, such as drop any persistent connections which have broken. And also complete any transactions that have timed out. Actually, when a transaction times out, should we close our connection as well? I guess that's up to the transaction object, right? Yes. Okay. So yeah. Okay. So standard thread worker. All right. So we need to have a worker thread method. Just copy this. Void worker. All right. So I have a constructor. I need to have a destructor, which means I need to have lifecycle methods. So here, just copy this boilerplate stuff over to here. It can remove that, and this becomes impl. Does client, what semantics is? Okay, they're all deleted. Okay. So here we will lock guard decal type mutex. So lock the mutex. Actually, I need to do this inside of a scope because I need to say stop worker true. And then worker wait condition notify. And then while not holding the mutex, say worker.join. And then I want to do all of this inside of a if worker.joinable. That's just a safe thing to do, even though our constructor is always going to create it. I'll just do that just to be safe. So here, worker equals standard thread impl worker this. I believe that's all I need to do. So worker gonna have a unique lock decal type mutex And it's going to say while not stop worker, it's going to say right now lock.wait. Oh no, worker wake condition wait lock, and then the condition right now is return stop worker. All right. Let me think about this. So that should not break anything. So let's try that out. It doesn't fix the bug though. I mean, not the bug, but it doesn't pass our test yet. We're not done. Right, so what do I want to do? So in broken delegate, I'll stop searching for all. Right here, where it's broken. I guess what I want to do is say transaction connection state broken equals true. Actually, why don't we just delegate it back up to the client? So is client going to live longer than everything else? That's a question. I suppose we can make that a requirement, that the users can't hold on to transactions after they've released or destroyed the client. Which means that it's safe to capture the client. So what we'll do is we'll have a broken delegate in the transaction itself. So okay, I need functional. We're going to make a delegate here. I forgot to document this. Okay, this indicates the current, indicates how far along in the transaction, how far along the transaction is. All right, so here's our delegate. This is the function to call if the actually, why am I even storing it in the transaction? I can just give it to the other broken delegate, can't I? Oh, and I was putting it in the wrong place anyway. Yeah, I can just add it here, so like this. And I can even put it here. So we'll make a broken delegate. So function, or really it's just const auto broken delegate equals, this is in client, so I can just capture this. There we go. So what do we want to do? Actually, I want to also capture the connection state weak. And I want to get back the connection state. Right, and then I want to grab, actually, do I even need to? All right, this is why I put it into a thread, because I don't, in the delegate, I don't want to grab the connections mutex. Actually, I do want to grab it. Maybe I don't need the worker for this then. I need to be careful not to repeat the mistake I made with the server, which was that a callback, right? A callback can lock the main object. In this case, is the client. We can grab its lock, but while we have its lock, we shouldn't try to get the locks of anything else. We need to establish basically a locking order. So right now, the only thing that gets that outer lock is the worker thread and our destructor. So we're safe so far. So if we get it here, though, we need to be careful that once we get it, we don't call anything else that might grab other mutexes. So lock guard decal type mutex. And in this case, it's impl mutex. So, yeah, I want to basically find that persistent connection again. This. Okay, I needed the server ID. Well, let's capture that. And then if we do find it, actually all we need to do is really just remove it, right? So I can really just say void persistent connections erase. Okay, so in addition to that, we want to grab, right, we want to grab, before we touch the persistent connections here, we want to grab the mutex as well. And we're going to do this. I'm going to limit the scope of that. Where do we use that entry? Okay, so we can limit the scope of it to just this part. This is what I want to avoid. I want to avoid getting the mutex of a connection state while holding the client's mutex. So we're only holding the client's mutex just to look into persistent connections. And also, I think we add to it at one point, don't we? Right here we do. Right, so do the same kind of guard this with a lockdown here. Although I don't want to do this, so I'll duplicate this code here just to do this last bit outside of the mutex. So this part here adds or drops the persistent connection, so we're going to hold on to the mutex in that case. After that, in addition, we do a break. Yeah, okay, so that should be good. Okay, I think everything is good. It's getting too complicated. Using mutexes makes things way too complicated. Well. We'll fix that soon. I think this'll do it. Let's give it a try. All right. Cool. So that was a broken connection, and it actually didn't need the worker thread stuff. So let me check this in, but without the worker thread stuff. So default everything staged, and then we'll go selectively remove. Okay, I don't need that functional. Oh, I needed it in a different place though. I needed it here. This needs functional now. This one did not need it though. So revert that. This was just missing documentation. Let me check that in by itself. Add missing documentation. All right. So just the source and the test. So the source functional. Okay, we don't want to stage that quite yet. Don't stage that. Don't stage that. Don't stage any of this yet. Right. None of this gets staged yet. Oh, I need at least one blank line staged, though. Stage one blank line, please. Okay, so we're adding a mutex. We're now, okay, the diff looks funky, but what we're doing is we're, in a critical section, we are looking up the persistent connections. Actually, here, I need to be careful here. Oh no, I don't. That's within the delegate. It doesn't have the client mutex at that point. Yeah, we're good. Same thing here, critical section. So this is detect server breaking. This is in the client. The server detect server breaking the connection. Breaking connections. All right. Oh, wait a minute. No, we already were detecting it. This is do not reuse persistent connections that are broken. So if a persistent connection breaks, remove it from the, drop it from the server, or drop it from the client. Yeah. Okay. Now, this worker thread, I'm going to pull this into the next change. The next change that was on the plan for today was handling connection response timeouts. So we kind of want the worker thread to wake up every once in a while and check to see if any transactions are timed out or any connections. So let's make a test for that. So this one is response timeout. Okay, so set up the client. We don't need that. Right. Have the client make a simple request. It doesn't matter if it's persistent or not. Or does it? Yeah, let's test two things at once. So this is more aggressive because we need to not only complete the connection with the timeout, but we want to make sure it's not reused. So let's put that 2 back in there. Response timeout, persistent connection, not reused. Okay. So make a persistent connection. Now instead of breaking the connection from the server end, allow enough time to pass such that the request will time out. We need to have like a timeout period as well. So maybe what we'll do is in the client, maybe you should make a dependency. In the server, we had configuration items. That was sort of a little bit of a complicated thing, though. And that was mostly because I wanted to have a configuration file, make it easy for a host of the client to use it. Maybe we don't need to go that far. Maybe I can just build it into the depths. So depths, we can put something there like request timeout. And we can just be arbitrary about it, right? So 1 second or something. So double. And then have a default request timeout seconds. This, I don't need to say seconds, do I? If I'd say seconds, I should say it in both. Let's say it in both, and it's explicit. This is the amount of time after a request is made of a server before the transaction is considered timed out if no response has been received. We'll say no part of it, because we'll have it just reset if we receive any data, because if it's a long download, it could take much longer than a simple request with hardly any data. So as long as we're receiving data, we'll be constantly resetting the timeout interval. We need to declare that. Right here. Const expr double is, I don't know, 10 seconds maybe? How long does Firefox usually, or Chrome usually wait for a server that takes forever? I guess we could try it. Let's see. So wserve, and then I need to make it build to have the debug symbols. Okay, I can't build it while it's running. Build, please. Then we run, and then, well, really, I should stage first, and then serve, and oh, not serve there, but serve here. I'm running the wrong thing. Okay, set the web server to start up, and then run. Okay, I forgot to set a breakpoint first. I wanted to, before we send the data here, have it hit a breakpoint. So if I go to localhost, and then if it's sitting there loading, how long does it take? I should have started a stopwatch. Okay, it was maybe 6 seconds after the minute when it started. Okay, while it's doing that, let's look up on Firefox. Just have to keep an eye and see if that times out eventually. So Chrome default request timeout. What is the default request timeout? Five minutes? It doesn't say if the timeout is for a request or something else, though. It seems like a long time, 5 minutes. Well, that's an idle socket. What about a request timeout? Doesn't seem right. It's an idle socket. It's where you're not making a request. It's sure taking a while, though. It's been over a minute. Maybe it does wait 5 minutes. It's exceptionally long. Well, there's no easy answer, so... And Chrome is taking forever. So how long would a typical user care to wait? Maybe longer than a second, but... 10 seconds would that be, is that a reasonable request timeout? If we don't get a single byte for 10 seconds? Yeah, we'll leave it at that. This is the default amount of time that can pass without receiving any data at all from a server before the client considers the connection to be timed out. I'm still waiting. If I close it though, it says no response. Oh, oops. Oops. Request timeout because I'm setting it there to 1. I'm setting it there so that we can go to our timekeeper. Okay, I need my own timekeeper. What would be a typical response time for the first byte? I would assume less than a few seconds. So being conservative and saying 10 seconds. I'm just guessing though. Okay, so here we say timekeeper. Current time is over the timeout. Then we will await the completion wait for the client transaction to complete, expecting a timeout. Expect equal HTTP ConnectionState should be client, right? Oh, we don't have one for that. Timeout, I guess. We'll have to add it. Broken timeout. The connection timed out waiting for a response from the server. Need to add it here. Timeout. Timed out. Okay, have the client make another, expect a new connection to be made. Yes, okay, so, yeah, all right. This will not work, obviously. We haven't written the code yet. Right, so it didn't time out. So let's do the timeout stuff. So in general, I think what we want to do, it'll be in the worker thread. Where is that worker thread? Here. So I think what we want to do, it's not the best. The best thing to do would be every time we wake up, we would reevaluate when the next timeout is. And then wait up to that amount of time and then check, right? But then every time we receive any data from any transaction, we'd have to wake up the worker to have it recompute that time. So I'm kind of opting for the cheap and easy, not cheap, but the slightly expensive but easy solution, which would be what we did in the server, I think. I had some kind of polling Right, a polling period. The server did sort of the similar thing. So every 50 milliseconds, we'll have it wake up and check. And right here. This is the number of milliseconds to wait between rounds of what polling connections. Yeah. Really, it's just connection polling period milliseconds. So worker, instead of waiting, it'll be wait 4. And then it'll be standard chrono milliseconds that. And then we don't actually care about the return value. It's probably a good idea to check when. Doesn't matter. So here we'll do the checking. So 4. Const auto reference persistent connection in persistent connections. Oh, let's get the current time. So const auto now after the wait would be good. Equals timekeeper get current time. So if actually persistent connection it's got a connection state in it, right? And then that has a connection. Is this where we want to put? I think this is where I want to put the last time, the time that the last data was received. Right, so if persistent connections last receive time minus now. Really, now will be greater. So if now minus that is greater than receive timeout. Is that what I called it? Request timeout. Oh, this current time is in seconds, right? Okay, so yeah. Greater than or equal to. Right, so here's where we got to be careful because I'm holding this lock, this mutex, and so what I want to do is subdue stuff with the transaction and the connection, but I don't want to do it while holding the lock. So what I'm going to do instead is I'm going to make a collection. Standard set of shared pointers to connection states. Timed out connection states. Oh, it was client connection state, wasn't it? Yep. And set, I don't think I included that. All right, so then we just do insert this guy. Don't care about the return value. And then while we have the lock unlocked, we need to remember to lock it at the end too. We will for auto timed out connection state. We can reduce this to connection state. Timed out connection states. We will basically do the timeout thing. No, it was like the broken. we have to complete it, right? Do this, right? So get the transaction and complete it. That much of it. So this is why I unlocked that, because I need to lock that one in order to get the transaction out. The transaction, I think this is safe because it gets its lock when I do call complete. And then after we complete the transaction, we want to remove it. So, okay. Remove it from persistent connections. Actually, we can do that earlier, can't we? We can do that up here. So instead of doing the for x:y format, we can say for the traditional one, which is for persistent connections entry equals persistent connections begin, persistent connections entry not equal to persistent connections end, and then no third statement. We say auto persistent connection equals persistent connections entry arrow second. And then I remove the second stuff. Right. So we insert it, and then we will do persistent connections entry equals persistent connections dot erase persistent connections entry. Otherwise, we just advance the, it's called an iterator, right? So this will drop the connection from our persistent connections while we're holding this lock. And then we unlock, and then the ones that we did time out, we will complete their transactions if they're still outstanding. And then I actually want to clear that, because that may drop the last reference to the connection. We want to do that while we're not holding the client mutex again, just to be safe. So we clear that out, and then now it's safe to lock again, and then we go back to sleep. That'll work. So we need to define some of these things. So request timeout seconds. We need to store that in our client implementation up here. Double, and we can default that again. Oh no, can we? It's declared here. Can I do that? Okay. And then let me copy the documentation for it. Whoa. What did I minimized something by accident. What did I do? Oh, minimized my console window. Hey, not Zane, what up? I'm actually 20 minutes from my end time, so I was just working on this one last thing. Actually, I'm almost done with the plan for today. This was sort of extra, but what I was working on today was kind of finishing up this HTTP client class. And I was hoping to get to this, but realistically, I think it's going to be tomorrow, where I make a program to use the client class to actually play with it and experiment with TLS. But I'm mostly just finishing up this client class today. And I think I'll end on time, which is nice. It's always nice to end on time and not have to go over or run out of things to do. Okay, so I'm gonna copy the documentation there, right? So what's up, Not Zane? How are you doing? This is the time after a request is made in the server, right? On time? Is there a meme for on time? What a concept, exactly. So we are missing this last receive time, which is important. Very important. So that's persistent connection client state here. So we're going to add it here. And we'll just default it to 0. And I'll say this is the time at which either the connection was established or the last data was received from the server, whichever was most recent. Okay, so we need to remember to set that when we do the connection. So where was that? That was in request, right? Where we make a new connection here. Right, so here's an important place to do it. So connection state last received time equals impl timekeeper get current time. And then we need to update it every time we receive a byte. So here. Third time's the charm. Okay. Oh, we need the timekeeper. Is it safe to hold a strong reference to timekeeper? I think so. So grab the timekeeper. I need to get a reference to it, don't I? So auto timekeeper, impl timekeeper. There we go. All right, let's try that out. Ooh, got a crash. Tuned in too late? Well, I'm still going for another 20 minutes or so. Yeah, but I'm generally noon to 3 p.m. Pacific time these days. I missed a couple days here and there. Yesterday I was working on catching up on some business stuff, and then I think it was Monday? I wasn't feeling well, and so I didn't stream then. So it's been sort of a light week. Okay, I was going to run this in the test framework to see where it crashes. Set up and go. All right, read access violation. Timekeeper is empty. Ooh. Ah, okay, yes. The worker is running before we're even mobilized. Let's move that then. School just started doing a minor on software architecture game development. I wish I could have studied game development in college. When I went to college, the best you could get was computer engineering, which was a mix between hardware or electrical engineering and software design. And the software design was like principles of like data structures, algorithms. If they had classes for game development, I definitely would have taken it. I know we did a little bit of OpenGL, but we didn't really do much. Kind of sad. Let's see. I don't want to have this running until the client is mobilized. I guess what we'll do is we'll just move this out, right? You showed up and they I missed one. You didn't know it was game development. Went there for software architecture, showed up and they were like, surprise, we're gonna make a game. Well, making a game is a good example to teach software architecture. And probably made the class or the is it the whole you're talking about a class, but it's more one of the classes in for your minor, yeah. So he probably picked game development just to get the students motivated and interested in the class. That's awesome. Sounds like an awesome professor. All right. I'm going to move this so that instead of being in the constructor, it's in a method called mobilize. And then we'll have a demobilize, which is called here. Demobilize. So we're breaking that out. So it still calls demobilize if it wasn't called, just to be safe. Everyone is visibly more excited and involved in the course than usual. Yeah. Makes me want to take that class. Okay, this method should be called when the client is mobilized in order to start background housekeeping. Okay, and then the reciprocal. This method should be called when the client is demobilized in order to stop background housekeeping. Then while we're at it, we'll make this fully symmetrical by setting that to false before we start the worker. And we should also say if it's not joinable. Like that. Doing it at another school though, so it's a 2-hour train ride? 2 hours. Well, at least you're on the train, so you could do coding or gaming or whatever on the train. I had to drive about an hour and a half to my job, which I really hated after a while. Am I not seem that long for Americans? It's a huge distance. I say it's long. Anything more than like 45 minutes is a long ways. Then again, I don't live in the Bay Area. If I did, maybe I'd be more used to it. I don't know. I probably would hate it just as much as I do in Southern California, so. Okay. Right, so we're not going to mobilize in the constructor, but we're going to call demobilize just in case in the destructor. The trick here is client mobilize needs to call impl mobilize, and then demobilize has got to do the reciprocal, impl demobilize. All right. Hopefully that fixes the crash. Sometimes you hear American media and people are like, yeah, we're going to Disneyland. It's just a 5-hour drive. Well, you don't go to Disneyland every day. 5 hours is crazy, though. I wouldn't do that to go to Disneyland. Okay, so it's not crashing anymore, but the timeout isn't really working. So let's see why. I'm curious why it didn't work. Okay, we should see that in the worker, right? So we should see the worker actually get to where it's checking states here. Let me... Disneyland Paris is a 3-4 hour drive. Yeah. I mean, if it was... I don't know. If you were really into Disneyland, it might be worth it. I guess it depends though, right? If you're really... if you're into it or not. G-test filter equals just the test I care about, which is got the word timeout in it. And let's set some more breakpoints. How about right before we advance the time and right after we wait up to 100 milliseconds for it to happen. Okay, then go. Okay, so here we're in the worker thread. And let's see. Last received time is 0, now is 1.5, and so it... Hold on. Oh, it never... Oh, I know, I forgot something. I always forget this. So we set it up, we had it defaulted, but I never copied it from the mobilize, right? Impl that equals deps dot that. Never connected the dots. That's what our unit tests are for, right? Okay, cool. So we're getting there. We expect timeout, but we got broken instead. I think that's just because I copy pasted a bunch of stuff, right? Yeah, so I made it say broken, and it really should be timeout. Cool, look at that. So I'm gonna end on time today. Oh, hold on. We broke a server test somehow. Interesting. Wahaha. Yeah, the universe conspires to keep me. What went on? What changed here? Port number changed from 80 to 81? What? Oh, okay, no, that's what it was supposed to do. Oh, I was comparing these two. I should be comparing these two. Okay, it's somewhere around here. Wait a minute. It says request timeout changed, request timeout changed. Did I do a search replace bug in the server? No, I didn't touch the server. Hold on. Is this a transient problem? It's only two tests. Really? I didn't even touch the server. How was this passing before? Oh, hold on. Maybe we have two names that are the same now. I think that's what it is. Yep. So the server has in an anonymous namespace that constant. Okay, yeah, this is not scoped correctly. This is a client default request timeout, so I guess I would list that as a public property. Normally you don't have public properties of classes, but in this case it's a constant. Can't change it, it's just a, yeah, just a constant. So we will say client. How come it doesn't like that? A non-static member reference must be relative to a specific, I think that's because I need to say, instead of just const, it's static const. Why doesn't it like me to say that? Really? Maybe I really just want to do that, but it doesn't like me saying that. Const expr is not valid in a class. Can I say static const expr? Okay, like that. All these silly rules of C++, like it should just figure it out, right? They say const expr here, it's of course static. Alright, that fixed it. So that was a symbol collision. I don't see that very often. That symbol collided with the one in server's anonymous namespace because it was in the global namespace scope. Which makes sense, it would collide. Oh, yes, we added timeout. Cool. Current time. Yes. Okay. Housekeeping for the client. Yes. Okay, so we didn't have that. Right, I didn't check the worker in previously, did I? Okay, I think we're good to go. So, client. Add mechanics for detecting server timeouts, server response timeouts. All right. I'm sad to say it though, but we're nearing the end of this stream today because I'm getting hungry. Let's run all of the tests to make sure I did not break anything else. Murphy's Law says something will break. The saddest. Okay, nothing is breaking. Everything checked in, correct? Yeah, while that's going on, let's do a little bit of a recap. So, Tuesday, I think it was. Yep, Tuesday. I started on this tangent of writing the client side of my web stuff. And I had this client class originally, but really it was only there to parse responses. So at first I did two things. So I gave it some implementation so that it could actually send requests and then wait for responses back. Then I also updated this response class itself so that it could be built incrementally. And that took a lot of time, so I didn't quite finish the client class on Tuesday. And so today I finished it. So I supported these 4 things. So reusing persistent connections, closing non-persistent ones, and then handling disconnections, and then timeouts. So I think that pretty much the class is complete now, and tomorrow I'll be working on a program to host this client, and then I'll be using it as sort of a sandbox to experiment with this libTLS. TLS stands for Transport Layer Security, and we will need that both on the client and the server side to do secure connections. So yeah, well, that's about it. Let's see who we can host. Sorry guys, but getting hungry and tired, so we will see who else is going. Interesting. Yeah, normally I would host someone like Adam13531, but he doesn't stream on Thursdays. I don't know very many other people who are streaming. Well, there's one game developer that I know of who's going now. Let me go see if she's. I don't know if it's a he or she. I'm sorry, but Ace Kikomo is going, and I'm looking at an ad now. Hold a sec, guys. I'm seeing ads for other people's channels. Okay, so he's still going. So let's go host him/her. This is a streamer who's doing game development, and it looks like it's in C#. So I'll introduce you to another game dev on Twitch, and hope to see you guys soon. Thanks for joining.